Picture this, a single moment, billions of years ago, when the universe was nothing but darkness and silence. Then, in an instant, a star, massive, ancient, and burning with unimaginable energy, reached the end of its life. It didn't fade quietly. Instead, it erupted in a blaze of light so powerful it could outshine entire galaxies. This was no ordinary star. This was a supernova, a cosmic explosion so immense it scattered the very building blocks of existence across the void. And here's the incredible part. Without that explosion, without that star's fiery end, the world as we know it, the air we breathe, the ground beneath our feet, even the gold in your jewelry, would not exist. Tonight, as you drift into the vastness of space, we'll explore the story of supernova, the universe's most powerful alchemists. These celestial events don't just light up the cosmos, they create the heavy elements that make up everything around us, from the iron in your blood to the calcium in your bones. It's a story of destruction and creation, of chaos and beauty, and it all begins with a single star's final act. So, wherever you are, whatever time it is, let's journey together into the heart of a supernova. Close your eyes, take a deep breath, and imagine yourself floating among the stars, where the universe's greatest mysteries unfold. By the end of this story, you'll see the night sky not just as a canvas of twinkling lights, but as a testament to the incredible forces that shaped our very existence. Let's begin. Now, let's take a closer look at what supernovae truly are. Imagine a star, not just any star, but one that's many times more massive than our sun. These stars burn brightly for millions, even billions of years, but like all things, they too must come to an end. When such a star exhausts its fuel, it doesn't simply fade away. Instead, it undergoes a spectacular and violent transformation, a supernova. A supernova is the explosive death of a massive star, a cosmic event so powerful it can outshine entire galaxies for a brief moment. This explosion releases an unimaginable amount of energy, enough to scatter the star's outer layers across vast stretches of space. But it's not just about the light show. Within that explosion lies something even more extraordinary, the creation of heavy elements. Think of supernova as the universe's ultimate forges. In the intense heat and pressure of these explosions, lighter elements like hydrogen and helium are fused together, forming heavier elements like iron, gold, and uranium. These elements are then flung into the cosmos, seeding the universe with the raw materials needed to form planets, moons, and even life itself. So, while a supernova marks the end of a star's life, it's also the beginning of something new. It's a reminder that even in destruction, there is creation, and as we continue our journey, we'll see how these cosmic explosions have shaped not just the universe, but everything within it, including us. Now, let's step back and trace the journey of a star, from its humble beginnings to its dramatic end. Every star begins its life within a nebula, a vast cloud of gas and dust scattered across the cosmos. Within these cosmic nurseries, gravity begins to pull the gas and dust together, forming a dense core. As this core grows hotter and denser, it ignites, and a star is born. The life of a star is a delicate balance between the inward pull of gravity and the outward push of nuclear fusion. For most of its life, a star burns hydrogen into helium in its core, releasing energy that keeps it shining brightly. But the fate of a star is not the same for all. It's the mass of the star that determines how it will live and how it will die. Smaller stars like our Sun have a relatively quiet life. After billions of years, they exhaust their hydrogen fuel and expand into red giants before shedding their outer layers, leaving behind a glowing core called a white dwarf. But for the most massive stars, the story is far more explosive. These giants burn through their fuel at an incredible rate, fusing heavier and heavier elements in their cores. When they finally run out of fuel, gravity takes over, causing the core to collapse. For the most massive stars, this collapse triggers a supernova, a cataclysmic explosion that marks the end of the star's life and the beginning of something new. So, while all stars share a common origin, their paths diverge dramatically based on their size, and it's this diversity that makes the universe such a dynamic and fascinating place. As we move forward, we'll see how these different fates shape the cosmos and everything within it. Now, let's turn our attention to the different kinds of supernova, the cosmic explosions that light up the universe and forge the elements we know and rely on. There are two main types of supernova, each with its own unique story and role in the cosmos: Type I and Type Roman II. Type I supernova occur in binary star systems, where two stars orbit each other. In these systems, one star is often a white dwarf, the remnant of a star like our Sun. When the white dwarf pulls material from its companion star, it can grow so massive that it triggers a runaway nuclear reaction. This explosion is so powerful that it completely obliterates the white dwarf, scattering its material into space. Type I supernova are known for their brightness and their ability to produce elements like iron and nickel, which are essential for the formation of planets and even life itself. On the other hand, Type Roman II supernova are the explosive deaths of massive stars, those at least 8 times more massive than our Sun. These stars burn through their fuel quickly, fusing heavier elements in their cores until they can no longer sustain the outward pressure needed to counteract gravity. When the core collapses, it triggers a shock wave that rips the star apart in a spectacular explosion. Type Roman II supernova are responsible for creating many of the heavier elements in the universe, such as gold, silver, and uranium, through processes like the rapid neutron capture, or R process. While both types of supernova play a crucial role in enriching the universe with heavy elements, they do so in different ways. Type I supernova are like cosmic recyclers, taking the remnants of older stars and transforming them into new materials. Type Roman II supernova, on the other hand, are the ultimate cosmic forges, creating elements that didn't exist before and scattering them across the cosmos. Together, these explosions ensure that the universe is constantly evolving, filled with the building blocks for new stars, planets, and even life. As we continue, we'll dive deeper into the incredible processes that take place during these explosions, uncovering how they shape the universe and everything within it. Now, let's take a closer look at what happens during the dramatic collapse of a massive star's core, the event that sets the stage for a Type Roman II supernova. Imagine a star many times more massive than our sun, burning through its fuel at an incredible rate. Over millions of years, it fuses lighter elements like hydrogen and helium into heavier ones, such as carbon, oxygen, and eventually iron. But here's where things take a dramatic turn. When the star's core fills with iron, it reaches a critical point. Unlike lighter elements, iron cannot be fused to release energy. Instead, it acts like a dead end in the star's nuclear furnace. Without the outward pressure from fusion to counteract the immense pull of gravity, the core begins to collapse. In a matter of seconds, the core shrinks from the size of a small planet to just a few kilometers across. This sudden collapse generates an enormous amount of energy, creating a shock wave that rips through the star's outer layers. The shock wave blasts the star apart in a spectacular explosion, scattering its material across space. This explosion is so powerful that it outshines entire galaxies for a brief moment. But the story doesn't end there. The intense heat and pressure during the explosion trigger a series of nuclear reactions, creating even heavier elements like gold, silver, and uranium. These elements are then flung into the cosmos, where they become the building blocks for new stars, planets, and even life. What's truly fascinating is how this process connects us to the universe. The iron in your blood, the gold in your jewelry, and the uranium used in energy production. All of these elements were forged in the hearts of massive stars and scattered by supernovae. Every time you look at the night sky, you're witnessing the aftermath of these cosmic explosions, the very events that made life on Earth possible. As we move forward, we'll explore what remains after a supernova, from the dense cores of neutron stars to the mysterious depths of black holes, and how these remnants continue to shape the universe. Now, as the dust from the supernova explosion begins to settle, we're left with some of the most intriguing remnants in the universe: neutron stars and black holes. These cosmic leftovers are not just fascinating in their own right, they also play a crucial role in the ongoing story of how heavy elements are created and spread throughout the cosmos. Let's start with neutron stars. When the core of a massive star collapses, it doesn't always disappear into nothingness. Instead, under the right conditions, it can form a neutron star, a city-sized object so dense that a single teaspoon of its material would weigh billions of tons. This incredible density comes from the fact that the protons and electrons in the core are crushed together, forming neutrons. Neutron stars are like cosmic powerhouses, spinning rapidly and emitting intense beams of radiation. Some of them, known as pulsars, flash like lighthouses across the galaxy, helping astronomers study the universe in incredible detail. But neutron stars aren't just cosmic curiosities, they're also key players in the creation of heavy elements. When two neutron stars collide, the resulting explosion, known as a kilonova, produces a flood of neutrons. These free neutrons are captured by atomic nuclei in a process called the rapid neutron capture process, or R process. This process creates some of the heaviest elements in the universe, including gold, platinum, and uranium. So, the next time you admire a piece of gold jewelry, remember that it might have been forged in the collision of two neutron stars billions of years ago. On the other end of the spectrum, we have black holes. If the collapsing core of a star is too massive to form a neutron star, it continues to collapse until it forms a black hole, a region of space where gravity is so strong that not even light can escape. Black holes might seem like cosmic dead ends, but they're far from it. They play a vital role in shaping the universe around them. For example, the material swirling around a black hole, known as an accretion disk, can heat up to incredible temperatures, emitting vast amounts of energy and even producing jets of particles that travel at nearly the speed of light. Black holes also contribute to the recycling of cosmic material. When they pull in matter from their surroundings, they can eject some of it back into space in powerful outflows. These outflows carry heavy elements forged in supernovae and neutron star collisions, spreading them across galaxies and seeding the next generation of stars and planets. Together, neutron stars and black holes are more than just remnants of stellar explosions. They're active participants in the cosmic cycle of creation and destruction. They remind us that even in the aftermath of a star's death, the universe continues to evolve, forging new elements and shaping the fabric of space itself. As we continue our journey, we'll explore how these heavy elements, scattered by supernovae and their remnants, become the building blocks for planets, life, and even the very atoms that make up our bodies. Now, let's take a closer look at the cosmic alchemy that happens during supernova, where the magic of neutron capture transforms simple elements into the heavy metals we know and value. This transformation occurs through two remarkable processes: the rapid neutron capture process, or R process, and the slow neutron capture process, known as the S process. Together, these processes are responsible for creating some of the heaviest and most fascinating elements in the universe. The R process, as the name suggests, is all about speed. It happens in extreme environments where there's an overwhelming abundance of free neutrons, like during the collision of two neutron stars or in the chaotic aftermath of a supernova explosion. In these high-energy settings, atomic nuclei are bombarded with neutrons at an incredible rate. The nuclei capture these neutrons faster than they can decay, building up heavier and heavier elements in a matter of seconds. This rapid process is how elements like gold, platinum, and uranium are forged. It's like a cosmic pressure cooker, where the intense conditions force atoms to grow into some of the most precious and rare materials in the universe. On the other hand, the S process is a much slower and more gradual affair. It takes place in the interiors of aging stars, where neutrons are released at a steady pace. Here, atomic nuclei capture neutrons one at a time, with enough time in between for unstable isotopes to decay into stable ones. This slow and steady process creates elements like strontium, barium, and lead. Think of it as a gentle simmer, where the elements are cooked over millions of years, gradually building up their atomic weight. Both processes are essential to the diversity of elements we see in the universe. The R process gives us the heavy, exotic metals that are rare and valuable, while the S process fills in the gaps, creating a wide range of intermediate elements. Together, they ensure that the periodic table is rich and varied, with elements that form the building blocks of planets, life, and even the technology we use every day. As we move forward, we'll explore how these elements, forged in the hearts of stars and scattered by supernova, find their way into the fabric of the cosmos, shaping everything from the planets we call home to the very atoms that make up our bodies. Now, let's turn our attention to the unsung heroes of cosmic alchemy, neutrons. These tiny, uncharged particles play a crucial role in the creation of heavy elements, acting as the building blocks that allow lighter atoms to grow into heavier ones. Without neutrons, the universe as we know it would lack the rich diversity of elements that make up everything from the stars above to the ground beneath our feet. During a supernova, the intense energy and pressure create an environment where free neutrons are abundant. These neutrons, unbound to any atomic nucleus, are like cosmic seeds waiting to be planted. When they collide with lighter atomic nuclei, they are captured, adding to the nucleus's mass and transforming it into a heavier element. This process, known as neutron capture, is the key to creating the heavier elements that fill the periodic table. In the rapid neutron capture process, or R process, nuclei are bombarded with neutrons at such a high rate that they don't have time to decay. This rapid addition of neutrons allows the nuclei to grow quickly, forming heavy elements like gold and uranium in a matter of seconds. It's a chaotic, high-energy dance where the rules of atomic physics are pushed to their limits. On the other hand, the slow neutron capture process, or S process, is more like a leisurely stroll. Here, neutrons are added one at a time, with pauses in between for unstable isotopes to decay into stable ones. This slower, more methodical approach creates elements like strontium and lead, which are essential for the structure of planets and even life itself. Neutrons are the bridge between the light and the heavy, the simple and the complex. They allow stars to transform the basic building blocks of hydrogen and helium into the intricate tapestry of elements that make up our universe. Without them, the cosmos would be a far simpler and far less interesting place. As we continue, we'll see how these newly formed elements, born from the hearts of dying stars, are scattered across the universe, seeding the next generation of stars, planets, and perhaps even life. Now, imagine supernova as the ultimate cosmic alchemists, working in the vast laboratories of the universe. These stellar explosions take the simplest ingredients, hydrogen and helium, the lightest elements, and through their immense power, transform them into something far more complex and extraordinary. It's like taking a handful of sand and turning it into a masterpiece of glass, but on a scale that defies imagination. In the heart of a supernova, the conditions are so extreme that they rewrite the rules of chemistry and physics. Hydrogen and helium, the building blocks of the early universe, are fused together under unimaginable heat and pressure. This process, known as nuclear fusion, creates heavier elements like carbon, oxygen, and nitrogen, elements that are essential for life as we know it. But the alchemy doesn't stop there. As the supernova's shockwave ripples outward, it creates a chaotic environment where even heavier elements are forged. Elements like iron, gold, and uranium are born in this cosmic crucible, their atoms pieced together one neutron at a time. It's as if the supernova is a master chef, combining ingredients in just the right way to create a feast of elements that will eventually form new stars, planets, and even living beings. This process is not just a scientific marvel, it's a story of transformation and creation. Every atom of gold in a piece of jewelry, every speck of iron in your blood, and every breath of oxygen you take can trace its origins back to a supernova. These cosmic alchemists have shaped the universe into the rich, diverse place it is today, turning the simplest elements into the building blocks of everything we see and know. As we move forward, we'll explore how these newly created elements, forged in the hearts of dying stars, are scattered across the cosmos, setting the stage for the next chapter in the story of the universe. Now, let's take a closer look at how supernovae have left their mark on the periodic table, the very chart that organizes all the elements we know. Picture the periodic table as a cosmic map, and supernovae as the explorers who filled it with treasures. These stellar explosions are responsible for creating many of the elements that make up the world around us, from the air we breathe to the metals in our smartphones. One of the most fascinating contributions of supernova is the creation of elements like carbon, oxygen, and nitrogen. These elements are not just essential for life, they are the foundation of it. Carbon, for instance, forms the backbone of every organic molecule, from the DNA in your cells to the trees outside your window. Oxygen, on the other hand, is the breath of life, powering the energy processes in nearly every living organism. And nitrogen, though often overlooked, is a key component of proteins and DNA, making it indispensable for life as we know it. But supernovae don't stop at the elements that sustain life. They also produce heavier elements like iron, which plays a crucial role in the structure of planets and the blood that flows through your veins. Iron is unique because it marks the end of the line for nuclear fusion in stars. Once a star's core turns into iron, it can no longer produce energy through fusion, leading to the dramatic collapse and explosion of a supernova. Beyond iron, supernovae are responsible for creating even rarer elements like gold, silver, and platinum. These precious metals are forged in the intense heat and pressure of a supernova's explosion, where atomic nuclei capture neutrons in a process known as the rapid neutron capture process, or R process. This process is like a cosmic lottery, where the right combination of neutrons and atomic nuclei creates elements that are both rare and valuable. And then there are elements like uranium, which are not only heavy, but also radioactive. Uranium's creation in supernova is a testament to the extreme conditions these explosions produce. This element, though often associated with energy and weapons, also plays a role in powering the natural heat of Earth's core, driving the movement of tectonic plates and shaping the planet's surface. Every element on the periodic table has a story, and many of those stories begin in the heart of a supernova. From the lightest elements like hydrogen and helium to the heaviest like gold and uranium, supernovae have shaped the chemical makeup of the universe. They've turned the simplest ingredients into a rich tapestry of elements that form stars, planets, and even life itself. As we continue, we'll see how these elements, forged in the fiery hearts of dying stars, are scattered across the cosmos, setting the stage for the birth of new worlds and the endless cycle of creation and destruction that defines our universe. Now, let's turn our attention to one of the most captivating elements, born from the chaos of supernova, gold. This precious metal, cherished for its beauty and rarity, has a cosmic origin story that begins in the heart of a dying star. Gold isn't just a symbol of wealth, it's a testament to the incredible forces at work in the universe. The creation of gold is tied to a process called the rapid neutron capture process, or R process. This occurs during the explosive finale of a supernova, where the intense heat and pressure create a flood of free neutrons. These neutrons are captured by atomic nuclei at an astonishing rate, transforming lighter elements into heavier ones. It's like a cosmic assembly line, where atomic nuclei are bombarded with neutrons, building up to form elements like gold, platinum, and uranium. What makes gold so special is how rare the conditions for its creation are. The R process requires an environment of extreme energy and density, something only a supernova can provide. In these fleeting moments, gold is forged, scattered into space by the force of the explosion. Over billions of years, these particles of gold become part of interstellar clouds, eventually coalescing into new stars, planets, and even the Earth itself. The gold we find on Earth today is a direct result of this cosmic alchemy. When our planet formed, it inherited these precious elements from the remnants of ancient supernova. Over time, geological processes brought gold closer to the surface, where it could be discovered and mined. Every piece of gold jewelry, every coin, every electronic component that relies on this metal is a piece of stardust, a relic of a star's explosive death. Gold's journey from the heart of a supernova to your hands is a reminder of how interconnected the universe is. It's not just a metal, it's a story of creation, destruction, and rebirth, written in the language of the cosmos. And as we continue to explore the universe, we're uncovering more about these extraordinary processes that shape everything around us. Next, we'll delve into why iron holds such a unique place in the life cycle of stars, and how its formation signals the end of a star's journey. Now, let's shift our focus to iron, an element that plays a pivotal role in the life and death of stars. Unlike gold, which is forged in the fiery chaos of a supernova, iron is created much earlier in a star's life, deep within its core. But here's the twist. Iron is both a product of a star's brilliance and the harbinger of its demise. Stars spend most of their lives fusing lighter elements like hydrogen and helium into heavier ones, releasing energy in the process. This fusion is what keeps a star shining, balancing the inward pull of gravity with the outward push of energy. But when a star begins to fuse elements into iron, something extraordinary and ultimately catastrophic happens. Iron is unique because it's the heaviest element a star can produce through normal fusion. Unlike hydrogen or helium, fusing iron doesn't release energy, it consumes it. This means that once a star's core starts filling with iron, it's no longer able to generate the energy needed to counteract gravity. The star's delicate balance is broken, and its fate is sealed. As iron accumulates in the core, the star's internal pressure drops, and gravity begins to take over. The core collapses under its own weight, triggering a chain reaction that leads to a supernova. In this explosive finale, the star's outer layers are blasted into space, scattering the elements it has created, including iron, across the cosmos. Iron's role in a star's life cycle is a reminder of the delicate balance that governs the universe. It's a symbol of both creation and destruction, a testament to the incredible forces at work in the hearts of stars. And just like gold, the iron we find on Earth, in our blood, in our tools, in the very ground beneath our feet, has a cosmic origin, born from the fiery depths of a dying star. Next, we'll explore how the heavy elements created in supernova become the building blocks for planets, including our own, and how these cosmic remnants shape the universe we know today. Now, let's take a closer look at how the heavy elements forged in supernova become the very foundation of planets like Earth. When a star explodes in a supernova, it doesn't just vanish into the void. Instead, it leaves behind a cosmic legacy, a cloud of gas and dust, enriched with heavy elements like iron, gold, and uranium. These remnants, scattered across the universe, become the raw materials for new stars, planets, and even life itself. Imagine a supernova as a cosmic gardener, sowing seeds of heavy elements into the vast expanse of space. Over millions of years, these elements mix with hydrogen and helium, forming dense clouds called nebulae. Gravity then takes over, pulling these clouds together until they collapse and ignite, giving birth to new stars. But the story doesn't end there. Around these young stars, the leftover material begins to clump together, forming planets, moons, and asteroids. This process is how our own solar system came to be. The iron in Earth's core, the silicon in its crust, and even the oxygen we breathe. All of these elements were once part of a massive star that ended its life in a spectacular supernova explosion. Without these cosmic furnaces, the building blocks of planets, and by extension, life, simply wouldn't exist. Supernova remnants don't just create planets, they also shape the evolution of entire star systems. As these remnants spread through space, they trigger the formation of new stars, creating a cycle of cosmic recycling that has been ongoing for billions of years. Each new generation of stars and planets carries with it the legacy of those that came before, enriched by the heavy elements created in the fiery hearts of supernova. So, the next time you look up at the night sky, remember that the stars you see are not just distant points of light. They are part of an intricate cosmic dance, one that connects us to the very origins of the universe. And as we continue our journey, we'll explore how this cycle of creation and destruction shapes the galaxies we see today, and how supernova continue to influence the evolution of the cosmos. Now, let's dive deeper into the cosmic recycling process, a breathtaking cycle that keeps the universe alive and evolving. When a supernova explodes, it doesn't just end a star's life, it sparks the beginning of countless new possibilities. The explosion sends shockwaves through space, scattering heavy elements like iron, carbon, and oxygen across vast distances. These elements, once trapped inside the star, are now free to mingle with the surrounding gas and dust, creating a rich cosmic soup. Over time, gravity begins to pull these scattered materials together, forming dense clouds known as nebulae. Within these nebulae, pockets of gas and dust grow denser and hotter, eventually igniting to form new stars. But the story doesn't stop there. Around these newborn stars, the leftover material begins to clump together, forming planets, moons, and even the building blocks of life. This process isn't just a one-time event. It's a continuous cycle that has been shaping the universe for billions of years. Each generation of stars and planets carries the legacy of the supernova that came before, enriched by the heavy elements they produced. It's a cosmic dance of creation and destruction, where the end of one star's life becomes the beginning of countless others. Think of it like a cosmic ecosystem where nothing is wasted. The iron in your blood, the calcium in your bones, and the oxygen you breathe, all of these elements were forged in the hearts of stars and scattered across the universe by supernova. Without this cycle of cosmic recycling, the universe as we know it wouldn't exist. As we look out into the night sky, we're not just seeing distant stars, we're witnessing the ongoing story of the universe's evolution. Each star, each planet, and each living being is a testament to the incredible power of supernova and the cosmic recycling process they drive. And as we continue to explore the cosmos, we'll uncover even more about how this cycle shapes the galaxies we see today and the life that may exist beyond our own world. Now, let's turn our gaze to the tools and techniques that allow us to witness these cosmic fireworks firsthand. Observing supernova is no small feat, but thanks to modern technology, astronomers have developed incredible ways to study these explosive events. Telescopes, both on Earth and in space, play a crucial role in capturing the light and energy emitted by supernova. From optical telescopes that reveal the brilliant flashes of light to radio telescopes that detect the invisible waves emitted by these explosions, each instrument provides a unique window into the life and death of stars. One of the most famous supernova in recent history is SN 1987A, which exploded in the Large Magellanic Cloud, a neighboring galaxy to our Milky Way. This event was a landmark in astronomy, as it was the first supernova visible to the naked eye in over 300 years. SN 1987A gave scientists an unprecedented opportunity to study the aftermath of a supernova in real time. By observing the expanding shock waves and the formation of new elements, astronomers gained valuable insights into how supernova shape the universe. But the story doesn't end there. Today, advanced observatories like the Hubble Space Telescope and the James Webb Space Telescope continue to push the boundaries of what we can learn. These instruments allow us to peer deeper into space and further back in time, capturing the faint light of supernova that occurred billions of years ago. Each observation adds another piece to the puzzle, helping us understand not just how stars die, but how their deaths contribute to the birth of new stars, planets, and even life itself. Supernova are more than just spectacular cosmic events. They are cosmic laboratories, offering us a glimpse into the fundamental processes that drive the universe. Through the careful study of these explosions, we've learned about the origins of heavy elements, the behavior of matter under extreme conditions, and even the expansion of the universe itself. Every supernova we observe brings us closer to understanding the intricate web of connections that bind the cosmos together. As we continue to explore the universe, supernova remain one of our most powerful tools for unlocking its secrets. They remind us that even in the vastness of space, every explosion tells a story of creation, destruction, and the endless cycle of cosmic renewal. Turning back the pages of history, we find that supernovae have long captured the imagination of humanity. One of the most well-documented examples is the Crab Nebula supernova, which lit up the skies in the year 1054. This extraordinary event was recorded by astronomers in China, Japan, and the Middle East, who described it as a guest star that shone brighter than Venus and was visible even during the day for nearly 3 weeks. These ancient observations provide us with a rare glimpse into how people of the past interpreted the cosmos, blending awe with a desire to understand the heavens. The Crab Nebula supernova wasn't just a fleeting spectacle. It left behind a legacy that continues to shape our understanding of the universe. Today, the remnants of that explosion form the Crab Nebula, a swirling cloud of gas and dust that serves as a cosmic time capsule. By studying this nebula, modern astronomers have been able to piece together the details of the supernova's explosion, revealing how such events scatter heavy elements into space and create the building blocks for future stars and planets. Historical supernovae like this one also highlight the enduring curiosity of humanity. Long before the invention of telescopes, people looked to the skies with wonder, recording celestial events and seeking patterns in the stars. These early observations laid the groundwork for modern astronomy, showing us that the universe is not static, but dynamic, filled with cycles of creation and destruction. The Crab Nebula supernova, in particular, reminds us that the cosmos has always been a source of mystery and inspiration, driving us to explore and understand the forces that shape our existence. As we reflect on these historical accounts, we're reminded that supernovae are more than just scientific phenomena. They are part of our shared human story. From ancient astronomers to modern scientists, these cosmic explosions have sparked curiosity, fueled discovery, and deepened our connection to the universe. They remind us that the stars above are not just distant lights, but active participants in the grand narrative of the cosmos, shaping both the universe and our understanding of it. Now, let's bring the story closer to home, because the legacy of supernovae isn't just written in the stars, it's woven into the very fabric of life on Earth. The heavy elements forged in these cosmic explosions are the building blocks of everything around us, from the air we breathe to the cells that make up our bodies. Without supernovae, life as we know it simply wouldn't exist. Take carbon, for example. This element is the backbone of all organic molecules, forming the structure of DNA, proteins, and even the sugars that fuel our bodies. Carbon's ability to bond with other elements makes it incredibly versatile, allowing it to create the complex chemistry that underpins life. But where did this carbon come from? It was born in the hearts of stars and scattered across the universe by supernova, eventually finding its way to Earth and becoming part of the cycle of life. Oxygen, another essential element, plays a crucial role in respiration, allowing our cells to produce energy. It's also a key component of water, which is vital for all known forms of life. Like carbon, Oxygen is a product of stellar processes, created in the cores of massive stars and released into space during supernova explosions. Without these cosmic furnaces, Earth's atmosphere would lack the oxygen we need to survive. Then there's phosphorus, a less talked about but equally important element. Phosphorus is a critical part of DNA and RNA, the molecules that carry genetic information and enable life to reproduce and evolve. It's also a key ingredient in ATP, the molecule that stores and transfers energy within cells. Phosphorus, too, owes its existence to supernova, which scattered it across the cosmos and allowed it to become part of Earth's chemistry. These elements, carbon, oxygen, phosphorus, and many others, are the gifts of supernova, delivered to our planet billions of years ago. They became part of the raw materials that formed Earth, and over time, gave rise to the incredible diversity of life we see today. Every breath you take, every beat of your heart, every thought you have is made possible by the elements created in the fiery deaths of stars. So, the next time you look up at the night sky, remember this: the stars above aren't just distant lights. They are the ancestors of everything around us, the cosmic alchemists that transformed simple elements into the complex chemistry of life. And in that sense, we are all made of stardust, connected to the universe in the most profound way imaginable. Now, let's zoom out from Earth and explore the broader cosmic picture, because supernovae don't just shape individual planets or life forms. They play a pivotal role in the evolution of entire galaxies. These explosive events are like cosmic gardeners, scattering the seeds of heavy elements across vast stretches of space, enriching galaxies and setting the stage for new generations of stars and planets. When a supernova occurs, it doesn't just destroy a star, it creates. The explosion sends shockwaves rippling through the surrounding gas and dust, compressing it and triggering the formation of new stars. This process, known as star formation, is fueled by the heavy elements forged in the supernova itself. Elements like carbon, oxygen, and iron become part of the interstellar medium, the vast clouds of gas and dust that fill galaxies. Over time, these clouds collapse under gravity, giving birth to new stars and planetary systems. Without supernova, galaxies would lack the raw materials needed to form stars and planets, leaving them barren and lifeless. But the influence of supernova goes even deeper. The heavy elements they produce don't just contribute to star formation, they also shape the chemical composition of galaxies. Over billions of years, successive generations of stars are born, live and die, each generation enriched by the elements created in the supernova of their predecessors. This ongoing cycle of stellar birth and death gradually increases the abundance of heavy elements in galaxies, a process astronomers call chemical evolution. The result is a universe that grows richer and more complex over time, with galaxies like our own Milky Way becoming vast repositories of heavy elements. This enrichment process has profound implications for the structure and behavior of galaxies. For example, the presence of heavy elements affects how stars form and evolve. Stars born in metal-rich environments, those with higher concentrations of heavy elements, tend to have different properties than those born in metal-poor regions. They burn their fuel differently, live longer, and often end their lives in different ways. This, in turn, influences the overall dynamics of galaxies, shaping their appearance and evolution over cosmic time. Supernova also play a role in regulating the growth of galaxies. The energy released in these explosions can heat the surrounding gas, preventing it from collapsing to form new stars. In some cases, supernova can even drive powerful winds that blow gas out of galaxies entirely, slowing down star formation and altering the galaxy's structure. This delicate balance between creation and destruction is a key factor in how galaxies evolve, ensuring that they don't grow too quickly or too slowly. In essence, supernova are the architects of galactic evolution. They enrich galaxies with the heavy elements needed for star and planet formation, shape the chemical makeup of the universe, and regulate the growth and structure of galaxies over billions of years. Without these cosmic explosions, the universe as we know it, filled with galaxies, stars, planets, and life, simply wouldn't exist. So, the next time you gaze at the night sky, remember that the stars you see are part of a grand cosmic cycle, one that began with the fiery deaths of ancient stars and continues to shape the universe today. Now, let's turn our attention to one of the most mysterious aspects of the universe, dark matter. While supernovae are known for their explosive brilliance and role in creating heavy elements, they also offer us a unique window into understanding this elusive substance that makes up a significant portion of the cosmos. Dark matter, which doesn't emit, absorb, or reflect light, remains invisible to our telescopes, yet its presence is felt through its gravitational effects on visible matter, including the remnants of supernova. When a supernova explodes, it doesn't just scatter elements into space, it also sends out light that travels across the universe. This light can be bent and distorted by the gravitational pull of massive objects, including dark matter. Astronomers use a phenomenon called gravitational lensing to study this effect. By observing how the light from a supernova is bent, scientists can map the distribution of dark matter in the regions surrounding the explosion. These observations provide critical clues about where dark matter is concentrated and how it interacts with the visible universe. Supernova also help us understand the nature of dark matter through their role in galaxy formation and evolution. The heavy elements produced in supernova mix with the interstellar medium, influencing how galaxies grow and change over time. Dark matter, which forms the invisible scaffolding of galaxies, plays a crucial role in this process. By studying how supernova and their remnants interact with the gravitational fields shaped by dark matter, researchers can piece together how galaxies are structured and how they evolve. One of the most intriguing connections between supernova and dark matter lies in the study of cosmic expansion. Supernova, particularly Type 1a supernova, serve as standard candles for measuring distances in the universe. Observations of these supernova have revealed that the universe is expanding at an accelerating rate, a discovery that led to the hypothesis of dark energy. While dark energy and dark matter are distinct, they are both fundamental to our understanding of the universe's structure and behavior. By studying supernova, scientists can refine their models of dark matter and its role in the cosmic web. In essence, supernovae act as cosmic probes, helping us uncover the hidden influence of dark matter. Through their light, their remnants, and their role in shaping galaxies, these explosive events provide invaluable insights into one of the universe's greatest mysteries. As we continue to study supernova, we move closer to unraveling the secrets of dark matter and its profound impact on the cosmos. Now, let's shift our gaze to another remarkable role supernova play in our understanding of the universe. They serve as cosmic timekeepers. These explosive events not only create the heavy elements that shape our world, but also help us measure vast distances across the cosmos and track the expansion of the universe itself. It's a story that begins with a special type of supernova, known as Type 1a, which has become a crucial tool for astronomers. Type 1a supernova are unique because they occur under very specific conditions. They happen when a white dwarf star in a binary system pulls material from its companion star until it reaches a critical mass. At this point, the white dwarf explodes in a supernova with a predictable brightness. This consistency makes Type 1a supernova what scientists call standard candles. Because we know how bright they should be, we can measure how far away they are by observing how dim they appear from Earth. This allows astronomers to calculate distances across the universe with remarkable precision. But the story doesn't end there. In the late 1990s, astronomers studying these supernovae made a groundbreaking discovery. They found that the light from distant Type 1a supernova was dimmer than expected, suggesting that the universe wasn't just expanding, it was expanding at an accelerating rate. This observation was completely unexpected and led to the hypothesis of dark energy, a mysterious force that counteracts gravity and drives the universe's accelerated expansion. This discovery fundamentally changed our understanding of the cosmos and earned the researchers the Nobel Prize in Physics in 2011. Supernova, particularly Type 1a, continue to be essential tools for studying the universe's expansion. By observing these cosmic explosions at different distances, scientists can map how the rate of expansion has changed over time. This helps refine our models of the universe's history and future, offering clues about the nature of dark energy and its influence on the cosmos. Without supernova, we wouldn't have the data needed to explore these profound questions about the universe's structure and destiny. In essence, supernova are more than just spectacular cosmic events. They are vital instruments in our quest to understand the universe. Through their light, they help us measure distances, track the expansion of space, and uncover the mysteries of dark energy. As we continue to study these cosmic timekeepers, we gain deeper insights into the forces that shape the universe and our place within it. Now, let's turn our attention to something truly extraordinary: the sound of supernova. While we often think of these cosmic explosions in terms of light and energy, they also produce something far more subtle, yet equally fascinating: shockwaves that ripple through the fabric of space-time itself. These ripples, known as gravitational waves, allow us to hear the universe in a way that was once unimaginable. Imagine dropping a pebble into a still pond. The ripples spread outward, carrying energy across the water's surface. In a similar way, when a supernova explodes, it sends out shock waves that travel through space-time, creating ripples that stretch and compress the very fabric of the cosmos. These ripples are gravitational waves, and they carry information about the cataclysmic event that created them. But how do we hear these waves? Just as sound waves vibrate our eardrums, gravitational waves vibrate the detectors here on Earth. Instruments like LIGO, the Laser Interferometer Gravitational Wave Observatory, are designed to pick up these tiny vibrations. When a supernova explodes, the shock waves it produces can be detected as faint signals, almost like whispers from the distant universe. These signals provide a new way to study supernova, complementing the light and energy we observe with telescopes. Gravitational waves offer a unique perspective on supernova. Unlike light, which can be blocked or distorted by dust and gas, gravitational waves travel unimpeded through the universe. This means they can give us a clearer picture of what happens during a supernova, especially in the moments just before and after the explosion. By listening to these cosmic ripples, scientists can learn more about the inner workings of massive stars and the forces that drive their explosive deaths. The ability to detect gravitational waves has opened up a whole new field of astronomy, often referred to as multi-messenger astronomy. This approach combines observations of light, particles, and gravitational waves to paint a more complete picture of cosmic events. Supernova, with their powerful shock waves, are a key part of this new era of discovery, helping us unlock secrets about the universe that were once hidden from view. In essence, supernova don't just light up the cosmos, they also send out ripples that we can now detect and interpret. These gravitational waves allow us to listen to the universe, revealing details about supernova that light alone cannot show. As we continue to refine our ability to detect these waves, we gain a deeper understanding of the forces that shape the cosmos and the incredible events that occur within it. Now, let's step into a different realm, one where science meets storytelling. Supernova, with their breathtaking brilliance and explosive power, have not only shaped the physical universe, but have also left a profound mark on human imagination. Across cultures and throughout history, these cosmic events have been woven into myths, legends, and artistic expressions, reflecting humanity's awe and curiosity about the heavens. In ancient China, for example, supernovae were often seen as celestial omens. The sudden appearance of a guest star, as they called it, was believed to signal significant events on Earth, from the rise of a new emperor to the fall of a dynasty. One of the most famous records comes from the year 1054, when Chinese astronomers documented a supernova so bright it was visible during the day for weeks. This event, which created the Crab Nebula, was interpreted as a message from the heavens, a reminder of the interconnectedness of the cosmos and human destiny. Similarly, in Native American traditions, supernovae were sometimes seen as the work of powerful spirits or deities. The Navajo, for instance, tell stories of the hero twins who journeyed to the sky and transformed into stars. The sudden appearance of a supernova might have been interpreted as a sign of their presence or a moment of divine intervention, a reminder of the sacred balance between the earth and the sky. In Western culture, Supernovae have often been associated with transformation and renewal. The explosion of a star, while destructive, also creates the building blocks for new stars, planets, and even life. This duality has inspired countless works of art and literature. For example, the Romantic poets of the 19th century often used celestial imagery to explore themes of creation and destruction, seeing in the stars a reflection of the human condition. A supernova, with its fleeting brilliance, became a symbol of both the fragility and the enduring power of existence. Even in modern times, supernovae continue to captivate the imagination. They appear in science fiction as symbols of cosmic change, or as dramatic backdrops for stories of exploration and discovery. Films, novels, and even video games often use the imagery of a supernova to evoke a sense of wonder and the vastness of the universe. These cultural representations remind us that supernovae are not just scientific phenomena, they are also a source of inspiration, a way for us to connect with the mysteries of the cosmos on a deeply human level. Supernovae, in their many forms, have become a bridge between the scientific and the symbolic. They remind us that the universe is not just a collection of physical processes, but also a canvas for our stories, our fears, and our dreams. As we continue to explore the cosmos, we carry with us this rich tapestry of myth and meaning, a testament to the enduring power of the stars to inspire and transform us. And as we reflect on the cultural legacy of supernovae, we're reminded that these cosmic events are more than just explosions in the void. They are part of our shared human story, a reminder of our place in the vast, interconnected web of the universe. As we turn our gaze from the cultural echoes of supernovae to their scientific significance, we find ourselves asking a profound question. Could these cosmic explosions hold the key to life beyond Earth? The heavy elements forged in the hearts of supernovae are not just the building blocks of stars and planets. They are also essential ingredients for life as we know it. Without these elements, the complex chemistry that makes life possible simply wouldn't exist. Take carbon, for example. This versatile element, created in the fiery cores of massive stars and scattered across the universe by supernovae, is the backbone of organic molecules. From the DNA in our cells to the proteins that power our bodies, carbon is fundamental to life on Earth. But it doesn't stop there. Oxygen, nitrogen, phosphorus, and even iron, all of these elements, essential for life, owe their existence to the explosive deaths of stars. Without supernovae, the periodic table would be far emptier, and the universe far less hospitable to life. This connection between supernovae and life has profound implications for astrobiology, the study of life beyond Earth. When we search for habitable worlds, we're not just looking for planets in the so-called Goldilocks zone, where temperatures are just right for liquid water. We're also looking for planets rich in the heavy elements that make life possible. Supernovae, by seeding the cosmos with these elements, have essentially set the stage for life to emerge elsewhere in the universe. Every planet, every moon, every asteroid that contains these elements is a potential cradle for life, waiting to be discovered. But the story doesn't end there. Supernovae also play a role in shaping the environments where life might arise. The shockwaves from these explosions can trigger the collapse of gas clouds, leading to the birth of new stars and planetary systems. In this way, supernovae are not just creators of heavy elements, they are also architects of the cosmic neighborhoods where life might one day flourish. Imagine a distant star system born from the ashes of a supernova, with planets rich in carbon, oxygen, and other life-giving elements. Could life have taken root there? It's a tantalizing possibility. Of course, the search for extraterrestrial life is about more than just finding the right ingredients. It's also about understanding the conditions that allow life to emerge and thrive. Supernovae, with their ability to shape the chemical and physical landscape of the universe, are a crucial piece of this puzzle. By studying these cosmic explosions, we gain insights into the processes that make life possible, not just on Earth, but potentially on countless other worlds. As we continue to explore the cosmos, supernovae remind us that the universe is not just a vast, empty void. It's a dynamic, ever-changing place, filled with the potential for life. Every explosion, every scattering of heavy elements, is a step in the grand cosmic dance that could lead to the emergence of life elsewhere. And as we search for signs of that life, we carry with us the knowledge that we, too, are made of stardust, connected to the universe in ways we are only beginning to understand. With this in mind, let's turn our attention to the future of space exploration and how our understanding of supernovae might guide us in the search for life beyond our own planet. As we look toward the horizon of space exploration, the study of supernovae offers more than just a glimpse into the past. It lights the way forward. These cosmic explosions, which have shaped the very fabric of our universe, hold vital clues for humanity's journey into the stars. By understanding the heavy elements forged in supernovae, we gain the knowledge needed to explore and even settle on distant worlds. Consider this: every mission to another planet or moon relies on the materials and resources available in space. The heavy elements scattered by supernovae, iron, nickel, titanium, and more, are not just the building blocks of planets, but also the raw materials for future spacecraft, habitats, and tools. Imagine a future where astronauts mine asteroids rich in these elements, using them to construct bases on Mars or fuel missions to the outer reaches of our solar system. Supernovae, in a sense, have already provided the toolkit for our cosmic ambitions, but the role of supernovae in space exploration goes beyond just materials. These explosions also help us map the universe. By studying the light and energy from supernovae, scientists can measure vast distances across space, creating a cosmic roadmap for future missions. This knowledge is crucial for navigating the immense distances between stars and galaxies, ensuring that our spacecraft can travel safely and efficiently. Moreover, supernovae teach us about the environments we might encounter in space. The shock waves and radiation from these explosions shape the regions around them, influencing the formation of stars and planets. By understanding these processes, we can better predict the conditions on distant worlds, preparing for the challenges of exploration and colonization. For instance, knowing how supernovae distribute heavy elements can help us identify planets with the right chemical composition to support life or sustain human settlements. The study of supernovae also inspires innovation here on Earth. Technologies developed to observe and analyze these cosmic events often find applications in other fields, from medicine to energy. The same instruments that detect the faint light of a supernova millions of light years away could one day help us explore the depths of our own oceans or improve medical imaging techniques. As we venture further into the cosmos, supernovae remind us that the universe is not just a place to explore, it's a place to learn from. These explosions, which once seemed like distant, destructive events, are now seen as essential guides for humanity's future in space. They show us where to go, what to look for, and how to prepare for the challenges ahead. In this way, supernovae are not just remnants of the past, but beacons lighting the way to the stars. With this understanding, we can begin to imagine a future where the lessons of supernovae propel us to new frontiers, unlocking the secrets of the universe and expanding the horizons of human exploration. And as we take these next steps, we carry with us the knowledge that the stars themselves have paved the way. As we reflect on the vast tapestry of the cosmos, it's impossible to overlook the profound legacy left by supernovae. These colossal explosions are not just fleeting moments of destruction, they are the architects of the universe, shaping the very essence of everything we see and touch. From the stars above to the ground beneath our feet, the elements forged in the hearts of supernovae are the building blocks of existence itself. Think about the air you breathe, the water you drink, and even the device you're using to watch this video. The oxygen in your lungs, the carbon in your body, and the silicon in your electronics. All of these elements were once scattered into space by the fiery deaths of massive stars. Supernovae are the cosmic factories that transform the simple ingredients of the early universe into the complex chemistry that makes life possible. Without them, the periodic table would be a barren list, and the universe as we know it would not exist. But the legacy of supernovae goes beyond just the elements they create. These explosions have shaped the evolution of galaxies, seeding them with the heavy elements needed to form new stars, planets, and even life. Every galaxy we see today, with its swirling arms and glowing cores, owes its richness and diversity to the countless supernovae that have erupted over billions of years. They are the cosmic recyclers, turning the ashes of old stars into the raw materials for new beginnings. And let's not forget the role supernovae play in our understanding of the universe itself. By studying these explosions, scientists have unlocked some of the deepest mysteries of space and time. Supernovae have helped us measure the expansion of the universe, discover dark energy, and even test the laws of physics under extreme conditions. They are not just remnants of the past, they are windows into the fundamental workings of reality. In a way, supernovae are the ultimate storytellers. They remind us that the universe is a dynamic, ever-changing place, where destruction and creation are two sides of the same coin. They show us that even in the most violent events, there is beauty and purpose. And they teach us that the elements that make up our world, and even our bodies, are the result of processes that began long before our sun and earth ever existed. So, as we gaze up at the night sky, let's take a moment to appreciate the legacy of supernova. They are the silent architects of the cosmos, the unseen hands that have shaped the universe into the rich, vibrant place we call home. And as we continue to explore the stars, we carry with us the knowledge that we are, in every sense, made of stardust, a living testament to the enduring power of these cosmic explosions. Now, let's turn our gaze to the human spirit and its unending quest to understand the mysteries of the universe. Supernova, with their explosive brilliance and cosmic significance, have long captivated our imagination and driven our curiosity to explore the unknown. These celestial events are more than just scientific phenomena. They are beacons that have guided humanity's journey to unravel the secrets of the cosmos. From the earliest civilizations to modern-day astronomers, supernova have sparked wonder and inspired questions about our place in the universe. Ancient cultures recorded these dazzling explosions in the night sky, often interpreting them as omens or messages from the gods. The Crab Nebula supernova, observed in the year 1054, was documented by Chinese astronomers and even noted by Native American tribes. These observations marked the beginning of humanity's fascination with the stars and laid the groundwork for the scientific study of the universe. Fast forward to today, and supernova continue to push the boundaries of our knowledge. They have become key tools for astronomers, helping us measure vast distances across the cosmos and uncover the nature of dark energy. The discovery that the universe is expanding at an accelerating rate, a revelation that earned the Nobel Prize in Physics, was made possible by studying the light of distant supernova. These explosions are not just cosmic events, they are milestones in our understanding of the universe's history and future. But the influence of supernova goes beyond science. They have inspired artists, writers, and dreamers, serving as symbols of transformation and renewal. From ancient myths to modern science fiction, supernova have been woven into the fabric of human culture, reminding us of the beauty and mystery of the cosmos. They challenge us to think bigger, to ask deeper questions, and to imagine what lies beyond the limits of our understanding. Perhaps most importantly, supernova remind us of our shared connection to the universe. The elements they create are the same ones that make up our bodies, our planet, and everything around us. In studying these cosmic explosions, we are not just exploring distant stars, we are uncovering the story of our own origins. Supernova have fueled our curiosity, driven our exploration, and deepened our appreciation for the vast, interconnected web of existence. As we continue to peer into the depths of space, supernova will remain a source of inspiration and discovery. They remind us that the universe is full of wonders waiting to be uncovered, and that our journey to understand it is far from over. So, the next time you look up at the night sky, remember that the stars above are not just distant lights. They are part of a story that began billions of years ago, a story that we are still writing today. As we shift our focus to the breathtaking spectacle of supernova, let's take a moment to appreciate their sheer visual grandeur. Imagine a star, once a steady beacon in the night sky, suddenly erupting in a burst of light so intense that it outshines entire galaxies. This is the awe-inspiring beauty of a supernova, a cosmic firework that illuminates the darkness with its radiant glow. The explosion sends shockwaves of light rippling through space, painting the void with hues of gold, crimson, and sapphire, as if the universe itself were an artist crafting a masterpiece. The brilliance of a supernova is not just a fleeting moment of beauty, it's a reminder of the universe's dynamic and ever-changing nature. These explosions are cosmic milestones, marking the end of one chapter and the beginning of another. They transform the familiar into the extraordinary, turning the remnants of a dying star into the seeds of new worlds. The light from a supernova travels across unimaginable distances, carrying with it the story of creation and destruction, of endings and beginnings. What makes supernova even more captivating is their unpredictability. No two supernovae are exactly alike, and each one offers a unique display of cosmic artistry. Some explode with a blinding flash, while others fade more gradually, leaving behind intricate patterns of gas and dust that glow for centuries. These remnants, like the Crab Nebula, become celestial canvases, showcasing the intricate interplay of light, energy, and matter. They remind us that the universe is not static, but alive with motion and transformation. Beyond their visual splendor, supernovae evoke a sense of wonder and humility. They remind us that even the most massive and enduring stars are not eternal, and that change is an inherent part of existence. In their explosive brilliance, we see the echoes of our own fleeting lives, and the realization that we, too, are part of this vast, interconnected tapestry. Supernovae challenge us to look beyond the familiar and embrace the beauty of the unknown. So, the next time you gaze at the night sky, let your imagination wander to the distant reaches of the cosmos. Picture the explosive birth of a supernova, its light traveling across eons to reach your eyes. In that moment, you are not just an observer, you are a witness to the universe's endless dance of creation and renewal. And in that dance, you'll find a beauty that transcends time and space, a beauty that reminds us of the infinite possibilities that lie within the stars. Now, let's take a step back and connect the dots between supernova and the very origins of our universe, the Big Bang. While the Big Bang set the stage for everything we know, supernovae play a crucial role in continuing that story, shaping the universe as it evolves. Think of the Big Bang as the opening act, where the simplest elements, hydrogen and helium, were forged in the fiery birth of the cosmos. But it's supernovae that take the baton, transforming these basic building blocks into the rich tapestry of elements we see today. When a supernova explodes, it doesn't just scatter stardust into the void. It enriches the cosmos with heavier elements like carbon, oxygen, and iron. These elements, born in the heart of dying stars, become the raw materials for new stars, planets, and even life itself. In this way, supernovae are like cosmic recyclers, taking what the Big Bang created and refining it into something more complex and diverse. They are the bridge between the universe's fiery beginnings and its ongoing evolution, but the connection goes even deeper. The energy released by supernova helps drive the formation of galaxies, seeding the universe with the elements needed for stars and planets to form. Without supernova, the universe would be a much simpler place, lacking the chemical richness that makes life possible. They are the cosmic alchemists, turning the raw ingredients of the Big Bang into the intricate structures we see today. Supernovae also remind us that the universe is a dynamic, ever-changing place. Just as the Big Bang marked the beginning of time and space, supernovae mark moments of transformation and renewal. They are part of a grand cycle where stars are born, live, and die, only to give rise to new stars and worlds. This cycle is the heartbeat of the universe, a rhythm that has been playing out for billions of years. So, when we look at a supernova, we're not just witnessing the death of a star, we're seeing a chapter in the ongoing story of the universe. From the Big Bang to the present day, supernovae have been shaping the cosmos, turning simplicity into complexity and chaos into order. They remind us that the universe is not a static place, but a living, breathing entity, constantly evolving and reinventing itself. And in that evolution, we find our own story, written in the stars. As we gaze into the future of astronomy, the study of supernovae continues to hold immense promise. Upcoming telescopes and missions are set to revolutionize our understanding of these cosmic explosions and their profound impact on the universe. One such groundbreaking project is the James Webb Space Telescope, which will peer deeper into space than ever before, capturing the faint light of ancient supernovae and shedding light on the early universe. By studying these distant explosions, astronomers hope to uncover clues about how the first stars and galaxies formed, and how supernovae shaped the cosmos in its infancy. Another exciting development is the Vera C. Rubin Observatory, set to begin operations in the coming years. This observatory will conduct a massive survey of the night sky, detecting thousands of supernovae and providing unprecedented data on their frequency, brightness, and distribution. With this wealth of information, scientists aim to refine their models of stellar evolution and better understand the role of supernovae in enriching galaxies with heavy elements. In addition to these telescopes, missions like the European Space Agency's Athena X-ray Observatory will focus on the remnants of supernovae, studying the hot gas and shock waves left behind by these explosive events. By analyzing these remnants, researchers can piece together the processes that occur during a supernova, from the collapse of a star's core to the dispersal of elements into space. This knowledge will not only deepen our understanding of supernovae, but also provide insights into the life cycles of stars and the formation of planets. Looking even further ahead, advancements in gravitational wave astronomy promise to open a new window into the study of supernovae. Instruments like the Laser Interferometer Space Antenna, or LISA, will detect ripples in space, time caused by the violent deaths of massive stars. By combining gravitational wave data with traditional observations, astronomers hope to gain a more complete picture of supernovae, from the moment of explosion to the creation of neutron stars or black holes. These future missions and technologies are not just about observing supernovae, they are about unraveling the mysteries of the universe itself. Each new discovery brings us closer to understanding how supernovae have shaped the cosmos, from the formation of the first stars to the creation of the elements that make up our world. As we continue to explore the universe, supernovae will remain a key piece of the puzzle, guiding us toward a deeper understanding of the forces that drive the evolution of galaxies, stars, and even life itself. The future of astronomy is bright, and with it, our knowledge of these cosmic alchemists will only grow richer. As we bring our journey through the cosmos to a close, let's take a moment to reflect on the incredible story of supernova and their role in shaping the universe as we know it. These colossal explosions, the final acts of massive stars, are not just spectacular cosmic events. They are the very forges where the heavy elements that make up our world are created. From the iron in our blood to the gold in our jewelry, the materials that define life and civilization owe their existence to the fiery deaths of stars that once burned brightly in the night sky. Supernova are more than just explosions. They are cosmic recyclers, scattering the elements forged in their hearts across the universe. These elements become the building blocks for new stars, planets, and even life itself. Without supernova, the universe would be a very different place, devoid of the diversity and complexity that make it so fascinating. They remind us that we are all made of stardust, connected to the stars in ways that are both profound and humbling. As we look to the future, the study of supernova continues to unlock the secrets of the cosmos. With cutting-edge telescopes and missions, we are poised to uncover even more about these cosmic alchemists and their role in the grand tapestry of the universe. Each discovery brings us closer to understanding not just the stars above, but also our place within this vast, interconnected system. So, as we conclude, let's take a moment to marvel at the wonders of the universe and the incredible processes that have shaped it. The story of supernova is a reminder of the beauty, power, and mystery that surround us. If this journey through the stars has sparked your curiosity, I encourage you to keep exploring. Look up at the night sky, learn more about the cosmos, and let the wonders of the universe inspire you. Don't forget to like this video, subscribe to the channel, and hit the notification bell so you never miss an adventure into the mysteries of space. Until next time, keep looking up. The universe is waiting to be discovered.